to solving rational equations and inequalities, and today we are looking for an LCM. Okay, so let's start with this first one. I've got 5, 6 plus 2 over x minus 6 equals 1/2. So the first thing I'm going to do is find my LCM. I have an x minus 6, I have a 2, and I have a 3. 6 is represented up there, x minus 6 is represented, and 2 is represented. I also need to pay attention to the fact that x cannot equal 6. So I'm going to take this LCM and I'm going to multiply each one of my terms by that. So when I multiply it, I'm going to cross off the 6 here and here, and I'll be left with 5 times whatever's left over, correct? So I'm going to write my 5. When I cross off the 6, the 2 and the 3 go away. What's left over? X minus 6. I'm going to undo that so I still have it. X minus 6. There's my first term. Plus 2 times, well, when x minus 6 goes away, what's left over? 2 times 3, which is 6, so that's going to be 6, equals 1 times, when my 2 cancels, what's left over? 3 and x minus 6. 3 and x minus 6. That's the hardest part, clearing that denominator. So then I just distribute. This is 5x minus 30 plus 12 equals 3x minus 18. 5x makes this nice and neat. 5x, negative 30 plus 12, negative 18 equals 3x minus 18. Subtract 3x from both sides. Add 18 to both sides. And we're left with 2x equals 0, therefore x equals 0. I need to check it. I'm going to check it in a different color. Check. I have 5, 6 plus 2 over 0 minus 6 is just negative 6 equals 1/2. 5, 6, this is actually, I can make this a positive, this a negative. 5, 6 minus 2 6s, 3, 6 equals 1/2. Check. It checks. Here are my steps. Identify LCM, multiply each term, distribute, solve, and check. Question. Ready to do one? Evan.
When you set and the common denominators don't equal?
You'd have to manipulate the denominators. Yep. Absolutely. Okay, find a common denominator, and that's how you check it. That's why you only have 10 problems to do, Evan. Okay? All right. You guys try this one. I'll go step by step with you. So just find the LCM first. What? You're racing me? I can't race you because I've got to check homework. Yes, sir. No. Thank you. Okay, here's my LCM. I need to record. Okay, that's what I got. When I canceled my 12, then this 12 canceled and I had 4 times x minus 4. That's why that's there. When my x minus 4 canceled, I was left with 12 and 4. And when my 48 canceled, I was left with x minus 4. So now we just need to distribute. Nine and 12 and 432. These combined together is 320. I'm going to add 220 to both sides and subtract 28x. What do I get? 540 equals what? Not 17, can't be 27. 27x. Divide both sides by 27. What'd you guys get?
20.
20 is right. What do I have to do with that? Check it. So I would get 7/12 plus 9 over 16 equals 55 over 48. Multiply this one by 4 and this one by 3, and you get 28 over 48 plus 27 over 48 equals 55 over 48, which is true. Check. Yes, it is.
In the homework, if you don't have to check it, like they don't want it.
They're going to ask you to check it. Okay. Ryan.
If you wanted to do, if you take the problem that you make from LCM and put your number in there, will it work?
Say it again.
When you solve the problem by distributing the LCM, so it's all without fractions, if you plugged it in there, would it work?
This one.
Yeah.
Should, yes. No. The reason why I don't think that would work, I have to think about that. I have to think about that because when you're multiplying by the LCMs, you're eliminating the denominator, and part of it being in the denominator is why you can't have some numbers that might see no solution. So if you're eliminating the denominator, that might affect it. I'll have to look into that, Ryan. It's a good question. Yeah, I need to think about it. All right, moving on. You guys ready?
Yeah.
Okay, pencils down. I'm going to do this one first. I'm going to rewrite it so we can see it a little bit easier. So this is 7n over 3 times n plus 1 minus 5 over 4 times n minus 1 equals 3n over 2 times n plus 1. Now we can see the LCM a little bit better. So my LCM is n plus 1 n minus 1, 3, 2, 2. I'm going to take that. You got it? Awesome? You good? That one multiplies to that, that one multiplies to that, that one multiplies to that. We should probably talk about excluded values. What can x not be? One and negative 1. All right. So I'm going to get to distributing. So I've got a 7n in the numerator, and I'm going to multiply that by whatever's left over. 3 and n plus 1 cancel. 3 and n plus 1 cancel. What's left over? And 4, right? 4 times n minus 1. 4 n minus 1. Next one, minus 5 times my 4 and my n minus 1 cancel. My n minus 1 and 4 cancel. What's left over? 3 and n plus 1. So 3 and n plus 1 equals 3n times 2 and n plus 1 cancel. 2 and n plus 1 cancel. What's left over? 6 and n minus 1. Good. 6 and n minus 1. All right. I know. Wouldn't that be nice to have that technology? It is really handy. 28n times n minus 1 minus 15 times n plus 1 equals 18n times n minus 1. Now I have 28n minus 28 minus 15n minus 15 equals 18n squared minus 18. You know what's really nice about this is you don't have to copy this. If you really want the extra notes, just go online on School and print them out. Yes? I missed it there, didn't I? 28n. Possum, you never sound stupid. No, seriously. Okay, there's no joke. That is not true. Okay, let's combine some like terms. What else did I do wrong?
28n squared minus 28n on the wall.
Thank you. Perfect. All right, so what else did you wrong? What is wrong? No, I told you, I already warned you guys, right? It's okay because I already warned you? Okay. I'm off. All right. So I've got a negative 28n and a negative 15n. So this becomes 28n squared minus 43n minus 15 equals 18n squared minus 18n. What in the world am I going to do with this? No, not put it into a calculator. It's quadratic. Well, we're going to factor it. But in order to factor it, I need everything on one side. So I'm going to subtract, I'm going to change my color first. Then I'm going to subtract 18n squared and add 18n to both sides. And I'm left with 10n squared. 25n minus 15 equals 0. Before, I don't need a box because I've got a GCF 2n squared minus 5n minus 3, right? Always looking for an easier way out, right, Ryan?
Yep.
So the way we roll?
Yeah.
Okay.
I like that box.
So, now that we factor out a GCF, I can now factor this straight. 2n, I don't need a box. Evan, sit up. 2n squared, I can factor that easily, right? That only has two factors, 2n and n. And 3 only has two factors, 3 and 1. So how do you want to make it? 1 and 3 or 3 and 1?
3 and 1.
Okay. You think that's going to work?
Yeah. Yeah. That's the 2 would be 5, wouldn't it?
No, it's not work for you.
Oh, yes.
I'll show you.
You got to go the other way. 1 and 3. Is that going to work? If I make this one negative and this one positive, I can do my rainbows and checks. Right, Matt? Rainbows and checks, remember that? And negative 6n makes negative 5n. That's what I needed, right? Not done yet. We're not done yet, though. No, not yet.
These are going to be on the homework a lot.
2n plus 1 equals 0 and n minus 3 equals 0. So n equals 3. Subtract. I should. Minus. The one you guys are going to do isn't as hard as this. Okay? 2n equals negative 1, or n equals negative 1 half. Those are my two solutions. What do I need to do with them? Okay, because of time right now, I am not going to check these. You know what I am going to check, though? So my check is missing. It's MIA right now. MIA. I am going to check this, guys. X can't equal 1 or negative 1. I don't have a problem because neither one of those are that, right? All right. We're only on, I have 6 examples. That's 3. We don't have. All right, you guys start number 2. All right, so I'm going to make sure I've got my LCM correct, first of all. So what is our LCM?
R plus 1 and R minus 1.
Thank you, Ryan. R plus 1 and R minus 1. Difference of 2 squares.
I remember something.
Good. So what can R not be? 1 and negative 1. All right, if this is my LCM, that's what we're going to multiply everybody by. That one, and that one. Do you guys want me to continue, or? Okay. All right, so when R plus 1 gets canceled, what is 2 going to be multiplied by? R minus 1. When R minus 1 gets canceled, what is left over? R plus 1 equals. When R squared minus 1 gets canceled, what's left over? Well, just the negative 2. Yeah. Okay. All right. So when I distribute, I get 2R minus 2 minus R. Make sure I see that subtraction sign. Minus 1 equals negative 2. 2R minus R is just R. Negative 2 and negative 1 is negative 3. We have a problem. Therefore, no solution. And that's your answer. Wasn't that a pleasant surprise? R equals 1, and we already know that R can't equal 1, so no solution. Question? Wait. Okay. All right, let's try one more, but this one's a little bit different. So my LCM on this one is a B, a 3, and a 5. However, B cannot be 0. To be or not to be?
They're trapped.
Okay, thank you. Back on track. To be or not to be?
That's the book.
Okay. 5, 4, 3, 2, 1. Back on track. So when I have a 1 and I'm going to multiply it by whatever's left over, a 3 and a B cancel. What's left over? 5 minus 5 and B cancel. What's left over? 2 times 3. We're going to forget about the inequality sign for now. And the 15 cancels. What's left over? B. This becomes 1 minus 6, which is
-5.
-1 equals B. Okay? All right. So from there, actually, I think I'm going to make these rise. Never mind. Guys, back on track. All right, so here's what we need to do. We have a solution, but B does not equal -1 because this is an inequality. So B is either less than -1 or greater than -1, and we need to figure that out. So we're going to draw ourselves a number line. We're going to draw ourselves a number line.
Yay.
And we're going to say, okay, my solution's right here. Sorry, I wanted that to be dashed. My solution is right here, which is at -1, or my solution is surrounding -1, right? That's what we're concerned with. But we have one other thing we have to be concerned with. What?
Can't be 0.
Can't be 0. Well, this is where the problem comes in. If I say that B is less than or greater than -1, that solution would include 0, right? So you've got to do what? Let's test some points. Okay.
Around 1.
It can't be. It just says less than.
It can't be 0 without the column.
Yes.
Can there be a hole?
Okay, I like that you're seeing that there's a hole. There is a hole. We're going to find it right now. But the hole's not at one spot because it's an inequality. It's a series. There's a big hole. Okay? All right. Okay, guys. So what would you like to test over here? Uh-oh. 1. So let's test 1. 1 over... If B was, let's erase this so we can see it. If B was 1, this would be 3. Minus 2 over 5 is less than 1/15. So what do I have to do, Evan? So multiply by what? 5 over 5 and 3 over 3. Gives me 5 over 15 minus 6 over 15 is less than 1 over 15. So -1 over 15 is less than 1 over 15. Is that true? It's true, therefore check. That's part of the solution. All right here is part of the solution. No, we're not done. That has nothing to do with anything over here. So what would you like to check first? -2. I'm guessing that if this is a solution, it's going to be here and here, right? Let's check. So I've got to check -2. -2. Sorry. Where did I go? It has to do with layers. Okay, so I have 1 over -2 would be -6. Minus 2 over -10 is less than 1/15. Like Evan was thinking, if this is a negative and negative becomes positive, what do I multiply everybody by? Or sorry, multiply this one. We could multiply everybody by 30, or we could just multiply this by 5, 3. It would have been easier to multiply everything by 30. Okay, so now I have 5 over negative 5, I should say, over 30, plus 6 over 30 is less than 2 over 30. Is 1/30 less than 2/30? Yes, therefore that one also checks. So we're all good. So my solution set is, what am I talking about? B, such that B is less than -1 or greater than 0. And that's my answer. Yeah, I'm not denying that it's a lot of work. You guys ready to do one? Try it. So, here is my beginning. Did you start it correctly? So I'm going to distribute now. I've got 6x minus 6 plus 30 equals 7x minus 7. 6x plus 24 equals 7x minus 7. Subtract 6x from both sides. Add 7 to both sides. Josiah, what do I get? $31 equals 1x. Here's my number line. Wouldn't that be nice? All right, so my solutions at 31, but where is my excluded value? 6. Therefore, what do you want to test? 10? Okay. Let's do some test points. Let's test something a little bit easier. Hold on. What's wrong? Yes. X cannot equal 1. Good catch. All right. Let's think of something other than 10. Look at Janelle. Do 6, because if you make it 6 minus 1, it'd be 1. It'd be 5, and that'd be 1. All right, if you want to see it, go ahead and stay. I'm almost done with it. Yes. 1. You guys try and be a little quiet so I can finish this off, okay? So 1 plus 5 over 5 is less than or equal to 7/6. I could actually change this. Thanks for being quiet, guys. This becomes 1 plus 1. So 2 is less than or equal to 7/6. Does that work? No. So if we plug in 6, which is in here, it does not work. correct? So since it doesn't work in there, it's going to have to be here and here. Does that make sense?
Yeah.
So now I've got, my solution is x such that x is less than, it can't be, it says less than or equal to, but it can't be equal to 1 because that would be an excluded value. So it's x is less than 1 or x is greater than or equal to 31. Patricia, does that make sense?
Yeah.
Like this one's greater than or equal to, this one's less than because of, it can't be 1. That's kind of tricky. All right, and we're done.
If I get out of here before 4, that's perfect.